Welcome back to a new machine learning tutorial. In this video we are going to talk about bagging classifier. We are going to talk about the logic behind the algorithm and how it works. Then we are going to code it using Python, and we are going to talk about how we can do hyperparameter tuning. Let's start coding. I'm in the Visual Studio Code interface. You can use any code editor that you want, it doesn't matter. I am going to create a file like bagging classifier, and it's going to be a Jupyter notebook. Next up, I'm going to select my kernel here, and I will write bagging classifier. And let's talk about it. So, bagging here is short for bootstrap aggregating. This is an ensemble machine learning method that improves model stability and accuracy. The main concept of bagging is to train multiple Bayes models, generally decision trees, on different subsets of the training data and combine their predictions to reduce variance. So our goal is reducing the variance. And this ensemble approach helps mitigate overfitting and improves generalization, making it a powerful tool for handling noisy data. So, step by step, we are going to select random subsets in bagging classifier. Next up, we are going to train individual models. And next, once the multiple models are trained, the weak learners, bagging combines their predictions. So we are going to combine their predictions. And our topic for this video is classification. So in the classification tasks, this typically means voting. So if model predicts a class label as A, then A becomes the final prediction. We can simply say like, let's say we have 7 different models and we have 2 classes to be predict, A and B. And 5 models predicts A and 2 models predicts B. Then in the voting, we are going to make the final prediction as A. Great, so now we can start coding. Let's start with the imports. I will say from scikit-learn.ensemble import bagging classifier. From scikit-learn.tree import decision tree classifier. From scikit-learn.datasets import make classification. From scikit-learn.model selection import train test split, and from scikit-learn.metrics import accuracy score. So we are going to use bagging classifier and decision tree classifier. In modeling side, we are going to create our data with make classification. Here we are going to use train test split for model evaluation, and we are going to use accuracy score for evaluating the model results. We are going to compare the predictions of our model with true y values. And I have tutorials on all of these topics in my machine learning tutorials playlist. I'm going to type it, where you can find it from description and cards of this video where I talk about these topics. If you don't know them and want to learn more about the machine learning, you can check that playlist where I have more than 40 videos just like this one. So let's continue after the imports. The next step is going to be creating the data. I'm going to create my data like x and y. We will use make classification. Number of samples is going to be 1000, and number of features is going to be, let's say, 20. And number of informative, I'm going to set this as 15, and I'm going to set the number of classes as 2. So at the x side, I'm going to have a matrix like this. I'm going to type x and run. So we have a matrix like this, and for the shape, we are going to see 1020 like this. And for the y side, we are going to have a binary classification problem. And at the shape side, we are going to see 1000 like this. We have a vector in y and matrix and x right now that we can work with. Great. Now it's time for initialization of the Bayes classifier. So I will say Bayes classifier, and it's going to be equal to the decision tree classifier that we imported in here. So I'm going to make this run, and I'm going to set bagging model, and it's going to be equal to the bagging classifier. I will say Bayes estimator is going to be equal to the Bayes classifier. And now I'm going to train my model. I will say bagging model.fit x-train and y-train. And before that, what I want to do in here is we will split our data in training and testing sets. So I will say x-train, y-train, y-test. Actually, x-test will be in here, and we will use train test split. and I will pass x and y. I'm going to set the test size as 0.2. I want 20% of the data is going to be in the testing set and 80% is going to be in the training set. So now I will also do import warnings, and I want to filter the depreciation and future warnings because they are unnecessary for this tutorial. Warnings, filter warnings, ignore. So after that we can train our model. I'm going to make this run and our model is trained. Now we can make predictions with it. Like I can say begging model predict, and I can pass x test, and we are going to get predictions. I'm going to store them in something like y predictions. Next up, I'm going to call accuracy score, and my accuracy score on this data is going to be 0.68, and I want a quite lower one, so I'm going to come to here and I'm going to decrease the number of informative count as 12, and I'm going to make them all run again. So we are going to get a new accuracy score of 0.80. Okay, so let's work with this. We have our base model right now, and now we are going to talk about hyperparameter tuning, which is the operation that we do for getting better performance from our models by optimizing their parameters. Let's talk about our parameters in Bayesian classifier. So we are going to start with base estimator. It is the type of model used as the weak learner. Typically a decision tree is used, but it can be replaced by any classifier like support vector machines or logistic regression. I'm not going to add that in parameter grid, but you can add them too. And we have number of estimators, and this is the number of base models in the ensemble. A higher number usually leads to better results but increases computational costs. And I will say max samples, it's going to be the next parameter that we are going to be talking about, and this is the number of features to draw from the dataset for training each base model. We are going to have bootstrap, and this is whether to sample the training data with replacement. It's defaultly true. And we have bootstrap features, and it means whether to sample the features with replacement, and it's defaultly false. So we are going to use grid search, which is going to try out all of these possible parameters that we give in the lists and return the best performing ones. So I will say firstly from Scikit-Learn model selection, I also have a tutorial on grid search. You can check my machine learning tutorials playlist if you want to learn more. And I'm going to define a parameter grid. I will pass number of estimators, and I'm going to give 10, 50 and 100. Next up, I will say maximum samples. I'm going to give 0.5, 0.8 and 1. Next up, I'm going to give maximum features. I'm going to give 0.5. By the way, you can extend these lists. I'm not going to do that because I want it to return back, but it's up to you. I will say bootstrap, and I'm going to give true with false. So after that, I'm going to make it run, and I'm going to set my grid search cross-validation object. And I will say grid search, it's going to be equal to the grid search cross-validation. Estimator is going to be the Bayesian classifier, and parameter grid is going to be the parameter grid. Cross-validation is going to be 5, and scoring is going to be accuracy. And I'm going to make it run right now. And now I'm going to train it like grid search.fit x train with y train. And when this finishes, I will be re-recording. It's returned in 48 seconds, and now we can see our best parameters. Like I will call best parameters on grid search like this. And true for bootstrap, 0.5 for maximum features, 0.8 for maximum samples, and 100 for number of estimators. And again, you can extend this list, like you can add 200 in here and try that one out. Next up, I'm going to say my best model, like grid search.best estimator, and I'm going to make predictions with it and compare the accuracy score with the base model. So I will say y prediction tuned, and it's going to be the best model dot predict. I'm going to predict the x test. Next, I'm going to call accuracy score with y test and y prediction tuned. And here is our accuracy score. It's 0.91. So it was I'm going to quickly check it. In here 0.80 and now it's 0.91. So we improved our model performance by parameter tuning. Great. Let's summarize what we did in this video. We start about talking about the backend classifier and the steps of it and the logic behind that. Then we create the dataset in here. We initialize the base model and set it the backend classifier, and we apply train test split. Next up, we train the base model and make predictions with it, store them in Y predictions and get the accuracy score on that. Next up, we talked about the parameters of the backend classifier and we imported grid search. We defined the parameter grid. Again, you can extend these lists. Next up, we set our grid search cross-validation object and we trained it. So we find the best performing parameters as true, 0.5, 0.8 and 100. Next up, we saved the best estimator for making predictions with it. We made predictions with the tuned model and stored them in Y predictions tuned, and we get the accuracy score of 0.91. That's it for the coding part. Let's get to the outro. Thanks for watching this tutorial on backend classifier. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.